So I want to review some algebra stuff that we've done before. We're going to need this for some of the geometry that we're going to do with circles. So we're going to review completing the square. And why complete the square? Well, let's look at what squares are first. Perfect squares. We know numbers are perfect squares. 16, for example, is 4 times 4. We know that 64 is 8 times 8, things like that. But what about polynomials? What polynomials are perfect squares? Well, if I take a polynomial that looks like this, that's a perfect square. Now let's just look at the polynomial part. The reason it's a perfect square is because it can be factored to look like this. Okay, which is basically x plus 3 squared. So this is what's known as a perfect square trinomial. And they're pretty easy to notice because what you notice about a perfect square trinomial is that the b term is actually the c divided by 2, or the square root of c times 2, okay? So really we could say that the b term is equal to the square root of c times 2. Or you could rewrite that to say that the c term is equal to b over 2 squared. And this is going to become important for us because this is what we're going to use to complete the square. This is something you've done before. What we're trying to do is we're trying to get to here so we can force perfect square trinomials. How did you use this last year? Well, you did quadratics. And you took a quadratic that looked like this, and you changed it using completing the square to put it in this vertex form, where h and k were the vertex of the parabola. So if you had your parabola looking like this little point here is hk. Okay? So that's what we're doing. Let's review how to do that. It's real simple. So here's my parabola. First thing you want to do, in fact, I'll do all 3 of these at one time, okay? First thing you want to do is make sure you have a leading coefficient of 1. So in this case, my leading coefficient is already 1. So this one's pretty cool. It's fine. It's happy. I love it. It's going to be golden. Here, it's -1. So we got to factor out that -1, except we're only going to factor it out of the first 2 terms. So this looks like negative x squared minus 6x, and we're going to leave the 11 on the outside. Over here, I see my leading coefficient of 5. So I'm going to do the same thing, factor it out, but only of the first 2 terms. Now we're set to complete the square, because what I want to do is I want to take those first 2 terms. In fact, here, I may even group them like that. Okay? Take those first 2 terms and create that perfect square trinomial. The way we do that is I'm going to rewrite it and leave a little bit of space in between for all of them. Little space. And here, this one's going to run off the paper probably. A little bit of space, and we're set there. Okay? So to complete the square, we're going to do exactly what I talked about at the top. Remember I mentioned up here, this c equals b over 2 squared? Well, we're going to find that c term. So in this case, I'm going to say my c equals 4 over 2 squared. 4 over 2 is 2. 2 squared is 4. So I'm going to add 4. If I'm adding 4 here, I got to balance it out by subtracting 4 there. Okay, and you did this last year. I can do the same thing here. My c term, don't even care about the negative, by the way. 6 over 2 squared. 6 over 2 is 3. 3 squared is 9. So I'm going to add 9 and subtract. Now be careful here, because it's actually a -9. So that turns it into a +9. Got to be careful with that. That's a mistake a lot of people make, to factor in this piece you factored out. Let's see. Here my c term is 2, so I divide by 2 and square it. So that's just 1. So I'm going to add 1, but be careful. Out here, 5 times 1, so I'm going to subtract 5. And then we just want to simplify all of that. Okay? Last step of this is to simplify and factor. So we created a perfect square trinomial here. So I know that's going to factor as something squared. And there's two ways to look at it. I could take the square root of this term, or I could take half of that term, okay? Either way, I know the last term is 2. The sign is going to follow whatever the b sign is. And in the rest of this, minus 9. So there's my factored. There's my hk. Same thing on this one. Y equals, I keep the negative. I know it's going to be something squared. So x, follow the sign in the middle. Square root of 9 is 3. Simplify that. And the same thing on the end here. Keep that. This now factors as something squared. X, follow the sign in the middle. Square root of 1 is 1. And over here I get minus 4. So that's how you used this last year. Now we also want to look at how this can be used to solve equations. So let's look at another example. To solve an equation, you're doing basically the same thing, okay? Except I'm going to, instead of, notice we're not equal to y this time, we're equal to 0, which is good because that's what you want to be when you're solving equations. So the first thing I'm going to do is I'm going to move the 6 to the other side. So that gives me x squared plus x. I'm going to leave some space and put the 6 over here. So now let's complete the square. My c term will be 1 over 2 squared. Oh, 1 over 2, well, if I square that, that's just 1/4. So I'm going to add 1/4 here and add 1/4 to the other side. Not subtracting this time because I'm balancing out my equation, keeping both sides equal. Okay, so add and add. And now I'm ready to do my factoring. Okay, this looks scary, but look how it factors. X, I'm going to square it, follow the sign in the middle, square root of 1/4 is just a half. Over here, I'm going to simplify this. I'm going to leave it as an improper fraction. So 6 would be 24 over 4. So that's 25 over 4. Now to solve this equation, all I need to do is take the square root of both sides and subtract 1/2. So when I do that, square root of 25 over 4, which by the way is equal to 5 over 4. Be careful here though. Here's where you got to make a catch. It's actually going to be positive or negative 5 over 2. I'm sorry, I said 5 over 4. 5 over 2. And subtract 1/2. This is where I get two separate answers. So I get x is equal to negative 1/2 plus 5 over 2, or x is equal to negative 1/2 minus 5 over 2. So x is either equal to 4 over 2, which is 2, or x is equal to negative 6 over 2, which is negative 3. Okay. Now, that's kind of silly. We could have factored that to begin with, but that's the idea. Let's look at another example, okay? So here, I'm starting out with a 2. So I'm going to move the 5 over. That's going to give me a 1 on this side. I'm going to factor out the 2. So that gives me x squared minus 2x. I'm going to leave some room. Okay? Just like we did with the parabolas. Now I'm going to get my c term. C is going to be 2 over 2 squared, which is just 1. So I'm going to add 1 to the inside here. Now over here, I'm going to add 2 times 1. So that's actually adding 2. Okay. Factor it now. So x, I'm squaring it. Follow the sign in the middle. Square root of 1 is 1 equals 3. And now we just solve this equation. So that's x minus 1 squared equals 3 over 2. I take the square root of that, positive or negative, square root of 3 over 2. So really, x equals 1 plus or minus square root of 3 over 2. I'm going to let you leave it right there, okay? Sometimes they want to break it up as 2 pieces. Sometimes they want to leave it right there. Running out of time on this one, so I tell you what, try the next one. Fractions get ugly here. See what you do on this one. So you tried this problem. Let's go over it and see how you did. My 18's already on the other side, so I'm in good shape. So x squared minus 7x, leave myself some space, 18. Let's find that c term. So c equals 7 over 2 squared minus 2x squared. Pretty ugly, but it's just 49 over 4. So I'm going to add 49 over 4, and I'm going to add 49 over 4. Yeah, the numbers are going to get ugly here, but that's okay. Not a big deal. This side actually factors pretty easily. X, followed a sign in the middle. 49 over 4 is just 7 over 2 when I take the square root. Now this, I got to simplify this. So 18 is really going to be 72 over 4. So when I add that to the 49 over 4, I get 121 over 4. Now I can square root both sides. When I do that, I get positive or negative. Square root of 121 is 11. Square root of 4 is 2. So now when I add 7/2, positive or minus, there we go. That's easy to compute. 7 plus 11 is 18 over 2 is 9. 7 minus 11 is 3, right? Double check my arithmetic. I feel stupid. 4. That's what I meant. So that's going to give me 2. So there's your solutions, 9 and 2. Okay? Which again, you probably could have gotten easily by just factoring this. But we want to practice at completing the square. So now that you've done that, there's a delta math for you that's going to review all of this information. I want you to complete this delta math, and all of this has to be done by Tuesday. We're going to be using this idea of completing the square with equations of circles. So if you're not practiced on this and not ready for it, you're going to be lost on that day. Okay? Go for it.